inside a polder. So this is looking out onto the Shipsha River, where outside the embankment on high tide, the water is up here. Inside the embankment, you can see the land surface is much lower than the tide. So this is why when anything breaches the embankment, as the storm surge from Isla did, the water just pours in, and the interior of the island was underwater for 9 to 14 hours per day. So this is a diagram showing the tidal range here. This thin black line is showing the tides going up to high tide, down to low tide. You see the spring tides here where they're larger, and the neap tides where they are smaller. Then my team surveyed outside and all the way across the polder at many transects, which are these colored dots here, which show that out on the riverbank terraces outside the polder, the height is here. And again, here's where the water is. So these riverbank terraces are below the water only occasionally on the spring high tides. Here is the polder height, and here is the interior, 1.5 meters lower than the exterior. Right on this one, it's roughly 1 meter, but before the islet, it was 1.5 meters lower than the exterior. And here is where the height of the floor of the Sundarban forest, right across the Naki River, is. And you see that the Sundarban forest, which is regularly flooded by the tides, maintains its level. The sediment naturally keeps the height of the land right up at the height very close to the highest high tides, whereas putting the polder in, preventing that flooding a few times a month, allows the subsidence, and the interior of the polder is now 1 meter below what the natural land level is. This makes the people much more vulnerable. Farther up on the river, it creates waterlogging. And we also determined that when the polder was breached, here was the height of the storm surge from Isla. When the polders were breached, this rapidly gained in a year and a half about 50 centimeters of height. So very rapid movement of sediment in and out. Inside the polders, the land is sinking because it has no sediment. The natural floods are blocked. Outside the polders, if the sediment cannot go on the land, it must go somewhere, and it will go into the river, and it starts closing up channels. So using satellite remote sensing imagery, we look, here is a region between Khulna here, a little bit northwest of Khulna. This is 1972. Look at where the rivers are. And then we see the same thing in 1989 with the outlines of the original rivers. And you can see the blue here where there's still water, but many regions like this have now filled in. They're largely silted up. The presence of polders, the presence of sluice gates interrupts the natural flow of the sediment, and there's been remarkable narrowing and silting up of many of these rivers. Here's 2015, even more degradation of the channels. So here, looking at 3 representative grid cells within poldered areas and 3 for comparison within the natural Sundarbans in 1973, using satellite imagery to construct the entire river network for Bangladesh, for this entire delta. And then here's 2013, and these dotted lines, the black and white dotted ones, are channels that used to be river channels that have now been completely blocked, silted up, and become Koshland. Whereas the Sundarbans, with no polders, the rivers remain Celtic. No major changes here, enormous changes up here. So here, looking at some of what we were just looking at, the river channel in 1973, the river channels in the same place in 2013, with all these dashed lines indicating obstructed tidal channels that have become Koshland, and the yellow lines indicate the embankments. This is a photograph showing where a channel used to be 300 meters wide. Now it's 20 meters wide. It used to be greater than 5 meters depth. Now it is only 1 to 2 meters of depth. Here is a channel located right here that was actively blocked off, silted in, and converted from a channel into agricultural land. Here, we're going to look at another point up here. So if we look at this region, channel was filled up, turned from a navigable channel into something that's been converted into aquaculture ponds for shrimp or fish. And so this is what the tidal channel was, now it is shrimp ponds. And so this control and degradation of the channels strongly impacts navigability. And our schematic here is if you have channels here with a polder on one side, a polder on the other side, the sediment cannot go on the land, so the land sinks down. Flooding hazards are greater. Waterlogging hazards are greater. 1 meter to 2 meters of subsidence over 50 years is typical. Within the channel, the sediment cannot go outside, so it settles in the channel and closes things off. And within these 3 squares that we studied intensively, there was a 59% loss of the drainage network. More than 1,000 kilometers of primary small creeks were obstructed. 54% of conduit channels were converted to Koshland. That's over 600 kilometers of river network that became non-navigable. And water then, that's removed from the tidal prism because the tides cannot flow in these blocked channels, gets concentrated into the remaining channels. So that's more than 1.4 or more than 1,400